So essentially, you have these reflexes in kids and in adults too, but you see it more in kids as they mature, as their brain develops. These reflexes drop, right? So you're
Mhm.
assessing whether these reflexes are apparent, and then you're also doing tests to look at the function of the nervous system. Correct.
Yep, absolutely.
So
And
what are just people listening? What are some of the just your top three tests that you look at to really get a window to how that nervous system's working?
uh, probably my favorite are the primitive reflexes. So the big one is if that child has a retained Moreau reflex, that's the baby startle reflex. If that's
Okay.
present, we're gonna have heightened
Mhm.
sympathetic nervous system activity. I like to look
Yep.
at the vagal system. If that vagal tone is low, we're gonna have digestive issues, immune system issues. We're gonna have social and emotional issues. That person is not going to be healthy by a lot of means. Then I like to look at eye function. I use both bedside and a system called Right Eye, where it's really cool. It's a computer with cameras at the bottom that watch how well the eyes move. So the kids and the adults stand in front of the computer and they just move their eyes and they're like, "Oh my gosh, this sees how my eyes are moving," and it's great. And it measures down to the micrometer how your eyes are moving. The eyes are a window into the brain, and that tells me a lot of information.
That's very cool. Now, when you're looking at the brain, right, there's different parts of the brain. We have, our cerebrum up top, and especially the frontal cortex, which is higher learning, problem solving, predicting outcome of actions, right, behavioral stuff.
Mhm.
And then we have the cerebellum in the back here, that big bump on the back. That's going to be more balance. It's going to feed into the cortex, but it's mainly on balance side of the fence. And then we have our brain stem in the back, which is going to have, medulla pons, midbrain, which is going to have a lot more of the, blood pressure, breathing, respiration, but a lot more of that kind of amygdala fight or flight response. Is that correct?
Yep. Yep.
And so when
And those
you're looking at a patient, are you looking at these different imbalances in these different parts of the brain? Just can you go a little?
Yes. So I'm looking at all of that, and the brain develops from the bottom up, and I typically start the exam from the medulla, which is the lowest part of that brain stem, up to the pons, and then you said the midbrain, go into the limbic system. The cerebellum is huge. The
Mhm.
cerebellum, there's more neurons in that cerebellum than there is in your cortex. And the cerebellum,
Really?
yeah, the cerebellum is the master coordinator of the brain. It coordinates our motor function and our balance, but it coordinates our thoughts and it coordinates our emotions. So go to sleep thinking about that tonight. Uh, and then we go into the separate lobes of the brain: the occipital lobe, temporal lobe, parietal lobe, and of course the frontal lobes. And then we like to divide that out left and right and make sure we're having, uh, we're looking at the functions of all of that. And that's done with general core strength exercises, balance exercises, sensory integration checking, looking at how the eyes are moving. 5 major areas in the brain control how the eyes move. That's a great window into the brain again. Lots of checklists, because some of these things are cognitive and academic tasking, or logic and reasoning tasking. There's a lot of questionnaires and uh, uh, questionnaires and just standardized checklists that we use to look at this general function, and that gives us a great window in. It's Functional neurology is what I call the clinical application of neuropsychology, because a neuropsych
Mhm.
will take the neurology and then apply it to try to help them psychologically. That's what func neuro is. Whether we're working on a brain that's
Yeah.
demented or ADHD, we're looking at the areas that aren't working as they should because we know what's normal, and then we're usually going after the areas that are under functioning. You can go after the higher functioning areas, but
Mhm.
that's another topic.
Yeah. So when we look at this, functional medicine kind of, I think, dovetails perfectly with functional neurology.
Oh
Because
yeah.
we look at most neurologist tools, right? It's going to be mostly drugs. Very, very little on the surgery side, unless there's like some kind of an acute bleed. Then you're going to a neurosurgeon, right? But for the most part, it's going to be medication. Where we're looking at the cortex, we're looking at the hemisphere, we're looking at the different parts of the brain and how they manifest symptomatically with movements or functional testing. And then you're providing stimulus to bring some of those parts of the brain up. Can you just give me a couple of examples? Obviously, it's going to be specific. So if you're listening at home, like what are a couple of symptoms that you would see maybe with the cortex, hemisphericity, or a cerebellum? And what would be a couple of simple movements that could be done to bring one side up over the other?
Going back to the vagus nerve, that's probably the biggest one. So can't
Okay.
not, you can get a little hemispheric with working with that vagus nerve, but simple breathing techniques is going to activate that vagus
Hmm.
nerve. Applying heat on your abdomen will activate that vagus nerve. The vagus nerve controls all those organs down there, including digestion. And if you can tap into the physical attributes of that vagus nerve, that information is going to go in and talk to the corresponding areas that will eventually relay information up to the cortex that deal with social and emotional understanding. So, like in Office, for example, we have this device. We put a electrical pad on the person, like maybe on their left hand, or I might put on their left leg, and then we will put a probe on their left ear, and particularly on their Simba concha. And then we turn the probe on, and it's sending a little electrical signal in, and that's talking to the vagus nerve. And what's interesting is if I put it on their left hand, and then I bring on some vibratory tactile input on the rest of their left body, then that information is going to activate their right brain. And then their vagus nerve is getting activated at the same time. I might also use one of our cold lasers from Shed where I'll be shining light on their brain at the same time. I could also be running specific tones at the same time to get more hemispheric input into the brain to activate maybe the left or right side. So if I want to activate that right side more, I'm going to bring more sound in on the left side because 60% of your auditory input crosses over. Um, that's probably one of the best examples, and that's what we do quite a bit of because the rates of anxieties and depressions are up, and that is a pretty big function that is contributed by a lack of vagal tone input.
In the vagus nerve, essentially, it's a cranial nerve number 10, right? And vagus literally translates to the wanderer. So it wanders from the brain all the way down to the organs, and it hits that parasympathetic. That's kind of rest and relax, right? And so when we go parasympathetic, that takes us away from that brainstem amygdala kind of fight or flight response that's more sympathetic. Is that right?
Correct. Yep.
What else can we do that activates the parasympathetic in alignment with that vagus nerve?
So outside of breathing techniques, and there's simple breathing techniques like box breathing. People can look up box breathing. There's great tutorials online. You can look up 1-to-2 ratio breathing. So the amount of time you take breathing in, double it breathing out. Breathing in is a
Mm-hmm.
sympathetic nervous system activity. Breathing out is a parasympathetic nervous system activity. It's why when you are panicked or worked up, it's a good idea to breathe in, but breathe out very slowly because it's going to activate the parasympathetics. The other next best thing outside of, if we can go into nutritional means, is exercise. There's nothing that metabolizes cortisol better than actually sleep and exercise. If we can have the person move and get their heart rate up, there is no better prescription on the planet for getting that vagus nerve, that vagal system, to not necessarily directly engage, but secondarily engage because the frontal lobes are going to kick in more. We're going to have more endorphins. We're going to have better top down approach to that vagus nerve.
100%. One of the things I do with my patients, I do functional glucose tolerance testing. So we'll get a really good blood sugar meter. I like the Keto Mojo because it's got a Bluetooth link, so you can graph it to your cell phone. You can see the graph on it. So we'll do a before we eat test, and then we'll do a 1, 2 hour, 3 hour, and we can see how our blood sugar goes in that first couple of hours because that first hour or two is where we dump most of our insulin.
Sure.
And most people, they literally live their life on a blood sugar roller coaster. And when you spike up really high, you make a lot of insulin, your beta cells, the pancreas go crazy. And then a lot of times, if you're not fully insulin resistant or diabetic yet, now you have this reactive hypoglycemic drop. And then now your blood sugar goes to the floor. And now you're making lots of adrenaline and cortisol to pick up your blood sugar. And so when you do that, that creates more of this fight or flight sympathetic response. And when people say, how does exercise help with cortisol? Well, what happens is when you spike cortisol, you actually are mobilizing a bunch of glucose because prehistorically, stress and cortisol meant I needed to run or fight something and I needed instantaneous fuel for my arms and legs to use. The problem is when we're stressed at our computer or at our car, that glucose is like we just ate a freaking candy bar and now we're not using it. And so by getting some movement, even a simple 5 or 10 minute walk, that clears out the glucose from the cortisol, which then prevents that insulin resistance, inflammation kind of pathway from happening. Thoughts on that?
Yes. So I couldn't have said it any better. The one thing that comes to mind, if people don't already know this, because if we don't need to go into controversy by all means, but if autism does not bankrupt our country, then or dementia will. And
Yes.
in the world of research when it comes to dementia, and the most common form of that is Alzheimer's. In the world of research, it's called type 3 diabetes. Whenever it comes to a brain that is falling to dementia or degenerating, whether it's subclinical or clinical, there is always, always, always a blood sugar component. And there's always within that same system is the stress handling system. It's not going to be up to snuff to handle it. For people that are concerned about having a brain that might not be up to par one day, or you're concerned about your loved ones, it is keeping your blood sugar in a healthy range is what is number one. That is always what we go after before we even talk about working on your brain and having you come in the office and do fun brain exercises. I'm like, well, we got to go over what you're putting in your mouth and how much of it, because all of that work doesn't matter.
100%. I'm going to pull up a tab here. This is really important. So Blue Cross did a study, right? This is an in-house study with all the people that are Blue Cross insurance members.
Oh, wow.
And this came out right at the time of COVID, right? So this is like February 27, 2020. So you can go back in time and what was going on then. But this is crazy. So this is people that have Blue Cross. Check out these numbers. The numbers of diagnosed people with Alzheimer's and dementia in the 30 to 44 age group went up 373%.
What?
And among 45, yes, so 373% between 30-year-old to 44-year-old adults. This is crazy, right?